In the previous video, we have already discussed about the concept of trapezoidal rule and what is the use of trapezoidal rule in helping in finding the value, approximate a value of an integral, right? We have learned the formulas and the formulas of trapezoidal rule. So it's here I just teaching you how to using the trapezoidal rule, the formula. So it's like integrate from a to b for a function fx dx, which is the same as a 1 over 2 h, where the first value of y and the n value, right, means the last term of the y, shouldn't multiply with 2, and the second y value, the third y value, up to the second last y value, you have to multiply with 2. And this is the formula for trapezoidal rule, where h is defined to be b minus a over the number of subinterval that required. So let's see how to apply, right? How to apply this formula now. So in this question, I just want you to focus on how to apply this formula, right? So about the concept, I have already discussed in the previous video. So very simple. So by using trapezoidal rule, right? The question is scaling find integrate the integrand square root of 1 plus x squared dx from 1 to 2 by using the trapezoidal rule with 5 ordinates. Means you should not use substitution method or any method. So this is free from any techniques from the integration. So mainly here we are using numerical method, which is trapezoidal rule. Okay, so very simple. So as you know that you need to identify your a and b, right? In this case, your a will be 1, right? A to b, and your b will be 2, right? A is 1, b is 2. So very simple is the h, the value of h. So we have from this formula, just focus on this formula. The formula is there you have a half, then you have to find the h, and h is defined as b minus a over n, right? So you have to find the b minus a over n. But what is the value of n, right? What is the value of n? Very simple. So let's look at the question here. They are asking you to, by using the trapezoidal with 5 ordinates, all right? 5 ordinates. So when they said 5 ordinates, so we should analyze how many interval we have, right? So 5 ordinate means 1 ordinates, 2 ordinates, 3 ordinates, 4 ordinates, 5 ordinates. 1, 2, 3, 4, 5. We have 1, 2, 3, 4, 5. 5 ordinates. Among these 5 ordinates, we have 1, 2, 3, 4. We have 4 interval. Alright, we have 4 interval. Very simple. So if you have 6 ordinates, let's say if you have 6 ordinates, 1, 2, 3, 4, 5, 6. 6 ordinates, 1, 2, 3, 4, 5, 6. Then you have 1, 2, 3, 4, 5. 5 ordinates, right? If you have 8 ordinates, 1, 2, 3, 4, 5, 6, 7, 8. Very simple. You will have 7 interval. 1, 2, 3, 4, 5, 6, 7, right? So if you have means that from the A to the B here, we have divide that to 7 equal subinterval with 8 ordinates. So this is the meanings of ordinates here. Alright, so now we have understand what is the meanings of 5 ordinates, right? So we have n equals to 4. So then we can calculate the value of h. What is actually h? I still need to telling you. H is the length of each subinterval. Alright, so you have 1, 2, 3, 4, 5. 5 ordinates with 4 subinterval here, right? So it means that from 1 to 2, we have divided into 4 equally spaced, right? The length here. So it means that we take, if you understand the concept, it's even better to understand, right? For example, you take 2 minus 1. divided by 4. So you have getting 0.25 or 1/4, right? 1/4. So 1/4 is 0.25, right? So then if you add up this, because this is the length of 0.25, we're getting 1.25. Adding another 0.25, so you're getting 1.5. Adding another 0.25, we have 1.75. Of course, if you're adding another 0, you're getting 2, right? So it's exactly, we have 5 ordinates here. So what to do with these 5 ordinates? So these 5 ordinates, you need these 5 ordinates to find the value of y here. So you have to follow my procedure here. So very simple. So as we are suggested that we are using this table, right? This table to avoid careless mistake. So and this table is helpful, alright, in finding the trapezoid, the value of y1 and y2. So as we know that this is the value of ordinate, right? So we put as xi here. Okay, xi, the value of x here. Okay, this is actually the value of x. So we have the first one will be 1, right? 1.25. If we have 5 ordinates, then we have 5 rows with value, right? 1.5 and 1.75, right? 1.75 and 2. All right. Of course, the last one we need to add up also. Okay, we need to add up. Then we have so we have total. We have total in this column here. Okay, so then this will be the y, yi. Of course, you have x, you will have y, right? This is your y. Your y, integrate y respect to x. So which is square root of 1 plus xi square, right? Xi square. So means that if you have 1, then you have value of y1, x1, y1, right? You can get the value of y1. So, but based on this formula, you see that y1 and the yn. The yn means the last one here. So this will be your y1, y2, y3, y4, y5. Okay, so you have 5y here. So y1, so means the y1 and y5 is not multiplied by 2 according to the formula. It's not multiplied by 2. So very simple. So means that your y1 and y5, I will writing at this column, right? With all this is empty, right? Empty. And for this, the one that we multiply with 2 is y2, y3, and y4, right? So we have 1, 2, 3, 4, 5. The first and the last we put at the first column here. y1, y2, y3, y4, y5. Only y1 and y5 I leave it here. And for y2, y3, y4 I put it here. The purpose here is to get the total here and we multiply by 2. And this total we don't have to multiply by 2. This is the purpose lah, okay, of using this table here. So, alright, let's see how to get the value of y here by using calculator. Because we're not going to key in one by one. It's wasting of time, right? So we apply some technology, alright, a simple technology from calculator. Okay, let's see. Alright, okay, let's see what is my, I mean that by using calculator. Alright, so there's 2 model of calculator that I'm going to teach you how to using. So very simple, you just follow, be patient. Okay, so you look at this calculator. Okay, it's very easy. If you want to substitute one by one, it's okay. If you in one by one, right? So another way is by using this calculator. So you just going to the mode. Okay, make sure everything mode. Then you pressing this button, choose 9, right? The 9, the one that with 2 column here, 9. You choosing 9, right? After you choosing 9, they ask you for fx, right? As you know that this question, they ask you to integrate from 1 to 2 dx, and this will be your y, which is your fx. This will be your fx here. So you just key in the fx here to be square root of 1 plus alphabet x squared. Alright, You have key in this integrand here. So then you're pressing the button equal. Then there will appear to be another function, gx, right? So we don't have another function here, we only for one function. So this is not double integral. So what we do is, we just pressing 0 or just ignore it, okay? Pressing equal, right? 0, or you just ignore, because we just want fx. So now for start is a, start n, all right? This is we said from calculator, the language here, this is start, all right? And this will be n, all right? Start and n. So, and step will be the value of h. The value of h for this question just now, I've already found to be 0.25, right? H is, I take 2 minus 1 divided by the number of interval, which is 4, right? So I'm getting 0.25. So you have to make it clear, everything. Start and step. Okay, that's why you see this one, you have start and step here. All right. So start, you key in 1. All right. You key in 1. So 1 equal. Then they were moving down here. So not 5, because now it's 2, right? 2. So you just key in 2. Right? After you key in 2, you're pressing the button equal. Then they will go down. Now it's from 1 to 2 already. 1 to 2. Start and. So now step. The step here means the length of the interval, 0.25. So you just key in 0.25, right? 0.25. Then you're pressing the button equal. Then you're pressing the button equal again. So you are getting all the value. Can you see that? When 1, it will be 1.4142. Right? 1.25, it will be 1.6007. 1.5, this will be 1.8027. So it's accordingly, right? So for more accurate, we're pressing this button here. From here, you can see this is just 4 decimal places, right? Sometimes you need 6 decimal places here. If the question requests for 4 decimal places, hello, this is very important, okay, please listen. So if the question requests for 4 decimal places, so usually we will give 6 decimal places here. So finally, only we round off, right, to get the accuracy here. So now I'm pressing this button equal here. Can you see? Just now, 1, right? But you want to know is the value of y here, right? You want to know the value of y here. So, 1.4142 is not accurate enough. So you're pressing this button equal, go to this column. You can see that they're given a very accurate, right? More decimal places here. So this is the one. Okay, let's say this question, all right? The question asking you to give in 4 decimal places. So you're going to give extra 2 or extra 1, right? But you don't give exactly the 4 decimal places here. So then you record 1.414214, right? 4142 1.414214, right? 414214. So as I tell you before, the first and the last one, okay, we're going to record. So okay, the y1 and the y5, right? The rest. So now is y2, right? The second one will be your y2. So going down, then you're taking 6 decimal, 1.6000781, right? 1.6000781. So now go for the 1.5, right? The third value, y3. So this is your y1, this is your y2, and now I want to getting my y3. All right. So okay, so I'm pressing this button going down. So from the table is 1.8027. So from here, this is more accurate. 1.802776, right? You round off to 6 decimal places here. 2776, right? Okay, now go down again. So this will be your y4, right? Your fourth value, the fourth ordinates. So you will have 2.0155564, right? 2.15564. Okay, So I have record. So and the last value here, of course, you can't see from here, is the fourth value. So pressing this button going down, and then you will get the fifth value, which is 2, right? 2. So 2, you were getting 2 point, but I will putting the value here, the first and the last I will putting at this column here. So it will be 2.2360, right? 236068, right? 2.236068. So now already have all the value here. So now my job here is to get the total here. The total here. Alright, let's calculate the total. The total means for this one, I will total up these two, y1 and y5. Okay, this will be your y5. The first value of y and the last value of y will be at this column. So for this one, the middle one, y2, y3, y4 will be at this column here. So means there are no value here, no value here. So let's total up these two. Alright, okay. This will be my total. After I total these two, I getting this value. After I total up these three, I getting this value. Okay, so this is the way we're using this calculator, right? In this video, I'm going to show you using another calculator, as there are students that using this version and also this version of calculator. So very simple. So this calculator is also apply the same thing. Of course, you need to press on first, right? On. So mode. So in this case, the mode here, you're just choosing table, right? Table 7. Okay, 7. Then you repeat the same process here. So you're going to key in your fx to be square root of 1 plus alphabet x to the power of 2, right? Just pressing equal. So this one got no gx, so you just start. Start is what? 1, right? So you key in 1, 1 equal. Then n will be 2 equal. Then you have step 0.25. It's almost the same, okay? 0.25, then you're pressing equal. So then they will come up a table exactly as just now, the same thing. So for 1.25, 1.25 and 1.5, so you can get the value of x1, x2, x3, y1, y2, y3. So you're pressing the arrow here, so you will get exactly the same, 1.414214, right? 1.4142. So as you're going down, you have get all the value is the same, right? Going down again, you have 1.802776, and going down, and the last value will be 2.236068. Okay, so that's the way we're using all this calculator here. So we have all the value here. Now I'm going to teach you how to write your step. All right. Okay, so we have filled in all the table by using calculator, right? There is another way. You can just substitute one by one. 1 plus 1 square up to getting the value. 1 plus 1.25 square getting 1 by 1. You're going to key in. It's also okay. So now we have already getting all the value here. So now very important. Try to listen, because the purpose here is to how to use this formula, right? The trapezoidal rule, right? So okay, let's look at how to using that formula. So now, very simple. As for this, we want to integrate from 1 to 2. Approximate. This is actually another correct word. Is we are actually approximate, but we write equal here. Never mind. We just we have know that this is approximation. So we have know the value of AB. Okay, AB, and we just apply the formula, right? Half. So what is your H, right? What is your H? H, you know, which is the length of the interval, 0.25. So you just multiply with 0.25, all right? And y1 and yn, which means the first value, the total of the first and the last value. The total of the first and the last value. So you don't need to total already, because you already total up just now, right? So which is 3.650282, right? 3.650282, right? So we have recorded. So this is the total of y2 plus y3 plus y4. So means that the the middle one, right? The middle value. So with the middle value, we have to multiply with 2. That's why we do it different column here. So we're taking this 2, right? 2 multiply with the total of the middle value here, which is 5.419, right? 5.419121. So as we calculate all this by using calculator, we will get the value of this integral by using trapezoidal rule without applying any techniques of substitution, integration by parts, right? So let's calculate. All right, okay, this will be the value that we get, which is 1.8111 after we round off to 4 decimal places here. So for this question, I have to correct a bit. We have to find this one correct to 4 decimal places. Correct to 4 decimal places by using the trapezoidal rule. So it means that if they require you to find for 4 decimal places, usually it's just like Newton-Raphson method. We give extra 2 decimal places or 1 decimal places here. So all my lesson I will giving extra 2 decimal places here for accuracy here. So but this is just an approximate value for this. It's not the exact value. You have to understand trapezoidal rule is a rule in helping us integrate something without applying the integration by part substitution. It's just using the formula, right? As I already explained how to get this formula by using the sum of the area of all the trapezium here. I'm going to show you how you sure that this value is correct, right? The one that you approximate. You can using calculator in getting the exact value. All right, you can actually using calculator just by key in this, by getting the exact value, just what I get here. So I key in for you again. You just this one, then you key in from 1 up to 2, right? 1 up to 2. So we have square root 1 plus x squared, right? 1 plus alphabet x to the power of 2, right? So we have key in this one. So we're pressing the button equal. Then we were getting 1.8100914. So if you round off, the exact value here will be 1 point, the exact value. So what you get from calculator is the exact value. Alright, which they're using, maybe they're using an even higher approach, which you haven't learned in pre-university, okay, which is have a better approximation. There is other rule compared to with Simpson rule, okay, so which is 1.8101, right, and this will be 1.8111. This is a exact value for this. But what we get here is an approximate value, which is greater than the exact value, right? It's a greater than the exact value. But doesn't matter. If you round off to 2 decimal places, you will get exactly the same. All right. So this is the trapezoidal rule. We're using trapezoidal rule to approximate. Use the word approximate the integral, right? So okay, that's all for this video. I have teach you how to apply this formula.